Especially thank you, Dr. Cho, Dr. Bree, and Dr. Nisley for being on my committee. I really, really appreciate it. So my name is JT Kerr, but I know everybody here. Anyway, my name is JT Kerr, and I'm going to be presenting on the design, build, debut, and the improvement of MSU's new mascot vehicle, the Bully Car. I'm going to begin with a brief overview of the project, how it began, where the idea came from, and talk about an overview of my roles on the project. And after that, I'm going to go into the details of the automotive engineering class project that began the design and build of the car and my role in that class. And then talk about the summer and football season where the completion of the car was done, the finished construction, as well as the debut of the car during the football season. And then I'm going to finish with the series of improvements and updates that our team has been working on for the mascot vehicle. There's a huge number of people I need to acknowledge that helped make this project possible. Specifically, I want to thank the ME department and Dr. Mago, as well as CAVS and Dr. Walden for their funding support that helped make this project possible. And also Taylor Machine Works and Milwaukee Tool both made contributions to the project that helped make it possible, as well as a very large number of people with leadership and support and design and construction that helped make this project a reality. So first I'm going to begin with a brief background of where the idea came from. Shown here is the original vehicle that took Bully out onto the football field during games. It's been done for years. It's made of plywood. It's a doghouse on wheels, usually pulled by hand by about 4 or 5 different people. And before the football season of 2018, this car was beginning to be needing repair. Some of the plywood construction was beginning to deteriorate, and the paint was fading. And this kind of led to the idea that would become the Bully Car. The idea came from Dr. Andreas Strzelik to replace this vehicle with a self-propelled vehicle to carry Bully onto the field, which would make sense to promote our vehicle research at CAVS, as well as the engineering school here at MSU. And this idea was pitched to the athletic department, who approved the automotive engineering class to build a new self-propelled vehicle for Bully. And they also laid out a set of design requirements that it needed to meet, visual requirements, some features, as well as being done in time for the first home football game. Over the course of the Bully Car project, I worked on both management and hands-on work. I was primarily a manager as a graduate student during the automotive engineering class. Then during the summer, I was a member of the team that helped finish the build, continuing management work, and also getting a chance to work on design and hands-on work. After that, I was a member of the vehicle support team and the Bully Car 2.0 improvement team that rolled out the car, supported it through maintenance, and also has been working on improvements for the car. So now I'm going to go into detail about the automotive engineering class project that began the vehicle design process and talk about my specific roles on that class project team. The class began with design requirements from the athletic department. Most importantly, the Bully Car had to look like a doghouse, like the original vehicle. Additionally, it had to meet width and a weight limit in order to maneuver inside the stadium and also on the football field without tearing up the turf. Additionally, there was a CO2 tank feature that released a big cloud of smoke every time Bully comes onto the field, and they were very adamant that this feature be in the Bully Car as well. From there, a go-kart was chosen and purchased for the class to serve as the base of the Bully Car, a Tao Motors go-kart. This was chosen to meet initial budget constraints and also timeline constraints to give the class time to work on the car, but it didn't consider weight capacity when that vehicle was purchased. From there, the go-kart was delivered to the class, who took measurements of the car and began working on taking the visual concept that was approved by the athletic department and making that into a buildable design using SolidWorks CAD and measurements of the go-kart. A combination of student hands-on work and also donated services from Taylor Machine Works in Louisville came together to choose material, cut material, manufacture body panels, and create a welded frame for the bully car. The automotive engineering class was structured into 4 different design sub-teams for electronics, body design, assembly, and features, and also an engineering management team of 3 different students. The engineering managers worked to oversee the design sub-teams, help coordinate communication, and also work with the class professor on higher level decisions that needed approval. My specific responsibilities on the engineering management team fell into 4 different categories. In communication, I worked on keeping updates pushed out to students and informing the class professor of progress updates. And I also worked on a lot of planning, laying out deliverables to get the project done, and managing timelines for those deliverables. The engineering managers also handled the majority of the purchasing for the project, working with both local and online vendors to choose materials, look at lead times, and manage prices. Finally, the part of the point of the class was to allow students to do hands-on work on the car, and the engineering managers worked on scheduling hands-on work days to give students a chance to kind of get their hands dirty and work on the car. One of the first things I worked on was communication setup for the team, which I set up through Slack Messenger application. This was used throughout the course of the entire class project to communicate with individual students, also to distribute tasks, get those out, and also allow the design sub-teams to communicate with their members effectively. Additionally, I worked on a lot of planning of deliverables, and we used a Gantt chart throughout the project to manage different things that were dependent on each other. I worked with a variety of vendors, and some of the specific ones we worked with were Tigert Steel and Tupelo, where we purchased most of our raw material, as well as Precision Machine, who manufactured our body panels. And I, along with the other engineering managers, worked back and forth with them, doing quotes and getting lead times. Our team also owes a huge deal of thanks to Taylor Machine Works in Louisville, who reached out to the team during the project, and they donated welding services that were crucial to getting the frame of the bully car done before the end of the class project. And shown over here on the right is some of the other work that was not outsourced, students getting a chance to work on the car, install parts, and here taking measurements to make designs for the body. After the class project, there was still a body of work to be done to get the car ready to roll out for the first football game. So now I'm going to go into some details about that and my roles during that bit of the project. My responsibilities continued as a manager with a smaller team of about 5 people working on laying out the deliverables for the summer. Additionally, since it was a smaller team, I got a chance to work on design and hands-on work, specifically working on the rear entry stairs, the doors, the safety handrail, and also getting to do some of the hands-on work, helping one of our welders, and also working on the body panels. One of the first challenges our team had to overcome over the summer project was the mounting of the bully car body to the go-kart chassis. The body was made up of 2 halves, a truck cab and a truck bed, and my responsibility was the mounting of the truck bed. I designed a series of mounts using steel tube welded to the go-kart chassis, as well as a set of diagonal mounts that are not shown in this picture, but ran diagonally from the top rear of the truck bed to existing seat mounts in the go-kart chassis. Another thing our team worked on over the summer was several meetings with the athletic department to give them progress updates on the car, as well as get their feedback on some of our design decisions and help on some of the designs. And one of the areas where this was crucial was the design of the rear stairs. These were essential to the car to allow the mascot to safely and easily get on the car, but then get off when he was in the middle of the field. So something like a step ladder was ruled out early on. I ruled that out since it wasn't attached to the vehicle and wouldn't be practical for carrying onto the football field and being collected later. The idea I came up with was stairs integrated into the truck bed of the vehicle. And we got the athletics department's input on this during one of our meetings with them. I came up with a sketch and showed them the idea, pitched it to them, and they really loved the idea and wanted to make it happen. And they also provided input to us on the measurements needed for the area of the standing floor that the mascot would need to successfully or to safely be able to take steps forward and backward and have enough room without stepping backwards and stepping off the stairs. And those inputs were really crucial to making this design as safe as possible. Additionally, during another visit to Cavs, we had the mascot come out to Cavs doing some filming for a promotional video. And during that, we had the mascot walk up and down the stairs at Cavs. And we observed that the mascot could very easily and safely use those stairs. So measurements from those stairs are what the height and depth of the bully cart stairs are based upon. Another challenge for the team over the summer was adding doors, which was something I worked on. These doors had to serve two main purposes, which were hiding the driver from view, which was a big requirement from the athletic department. They didn't really want the crowd seeing a driver. And so these doors integrated a structure to mount a tinted window to hide the driver. And they also had to easily and safely open and close. So they integrated a set of off-the-shelf door latches and handles available at Lowe's. Shown here on your left is the completed stair frame after the material was cut and welded together and then welded into the truck bed of the bully car. Our team also owes a huge deal of thanks to Wesley Cameron at Cavs, who was not an initial team member of the project, but really liked the project and helped us out with several different welding tasks that were essential to getting the project done, including the work on these stairs. Some of the other work I worked on was the attachment of the body panels for the car. Shown here is just one of the pictures of one of the already attached panels with some of the measurement markings drawn on it. We're carefully aligning it with the other panels and measuring out where rivets would need to be placed. The finishing touches of the car to get it ready for the season were, most importantly, a safety handrail made from structural handrail, and then also some visual features like a hood ornament, a grille, headlights, and taillights. And the visual design was finished up by the athletic department, who contracted a local graphics company to install a vinyl wrap and add decals to the outside of the vehicle. And this was really important later in the project to make sure that the visual design met the specific requirements of the athletic department. And with that, the vehicle was finished and ready to roll out at the first football game. So now I'm going to talk about what I worked on during the football season and what maintenance improvements were done. The football season was utilized a vehicle support team, which was mostly made up of members from the summer build, including myself, who would at least one or two, usually two members of the team would be at a football game to do some pre-game checks, like checking the correct installation of the CO2 tank and running the driver through vehicle startup and other pre-game checks. And then after the game, the team would collect the car from the stadium and bring it back to Cavs to do inspections and look for areas that needed to be improved or could be improved between then and the next football game. The debut of the car was a big success, and it made it to every single home football game successfully. It dropped the bully off in the middle of the field, rolled out there, and then drove off the field under its own power every single football game. And in addition to that, the athletic department folks we were working with were really happy with it. They loved the way it turned out, and we've gotten some positive feedback from fans too. And here I've got just a short clip video of the rollout during one of the night games here. Got one of our stadium chants going on in the background. And yeah, we worked with the mascot a few times, and the mascot was just super happy with it. Loved to bounce up and down on it. In addition to its use on the field, the bully car also made a presence on social media leading up to and during the football season. There were a series of promotional videos across Facebook, Twitter, and LinkedIn. One of them promoting the car before it was unveiled, and another one after we hired Coach Leach to get on that hype train. And between these videos across social media platforms, its bully car has gotten about 120,000 separate views. And this is not counting numerous other posts from the MSU athletic department and the MSU Instagram and Twitter accounts. During the football season, our team learned a lot about how the car worked well, what worked well and what didn't, and certain areas and concerns that needed addressing to keep this car reliable and safe for future football seasons, so that this new MSU tradition could continue for years and years. The main concern that our team found was the vehicle weight. The early design made sure that the body was really sturdy and made from corrosion-resistant materials that would stand the test of time. But early design decisions in the project and the selection of the go-kart didn't consider weight capacity. And our team has found out, and the vehicle weight is over capacity by approximately 66% over the given weight rating of the Tal Motors go-kart. During the season, our team alleviated this problem, adding stiffer suspension components to the front and the rear, and this successfully got the car through the football season and helped it get on and off the field every game. But the remainder of the suspension and braking components are really not sufficient to handle this weight. And our team decided this is a big enough concern that it needs a change before bully car can continue on the field. The other main set of concerns that also stemmed from the go-kart were reliability problems with the engine. The engine is from an unknown manufacturer, and our best guess of our team is that it's a clone of a Honda scooter engine, which is very small for the size of the vehicle and is also very difficult to find parts and technical support for. And there were multiple maintenance procedures done on the car throughout the game. When there were hiccups in between games, when we were doing improvements, making sure that the car would start up correctly, and finding parts and online manuals very difficult for this engine. And additionally, it was a carbureted engine, which caused some problems during the especially cold games of the season, getting the car started. To address these concerns, our team has considered a variety of options, looking at the weight capacity of different vehicles, dimensions that would closely match the bully car and allow the reuse of the body designed and constructed, and also looking at price and time needed to implement the upgrade. The most attractive option our team has found is the Tracker OX400 utility golf cart, which has a sufficient payload capacity to carry the bully car, a mascot, and a driver, and also comes in at a reasonable enough budget to be purchased for the project. Additionally, our team is looking at future marketing use of the bully car to continue to use it as a tool to promote calves in the ME department, looking at coming up with an official name for the bully car, making it present on social media, and also unveiling Bully Car 2 at the Athlete Engineering Summit coming up on June 10th. Additionally, there's some special events going on during home football games, like Talk Like a Pirate Day, that we have some fun ideas that we think the bully car can take advantage of and generate a little bit of social media hype for the school. In summary, the bully car project was a big success and made it to every single home game successfully, and has even made a new MSU tradition for itself. The project has been big in scope, has been from spring 2019 to present with over 50 different people involved. And once again, I want to give special thanks to the MU department and CAVS for funding this project and making it possible and continuing to support it. And looking ahead, look for the unveiling of Bully Car 2 improvement sometime in the near future and on social media. A couple of references here for the different vehicles referenced. All right, that's the end. Thank you all so much for being here and for listening to me today. I'm now going to open up the floor for questions.
Any questions?
Thank you so much for coming.
It's a perfect example how a small class project can turn into something big.
Absolutely.
So, exactly right.
Absolutely.
Remember when Andre came with that idea, it was a small thing, and then,
Yeah.
it's really more than that, and it's exciting. So.
Small start, and it's really grown and grown.
Good job.
Thank you so much, sir.
Any questions?
How much pizza did you guys have to eat? What about the fuel you guys had to eat?
Let's see. I don't know that we ever ordered pizza at Cavs, but the last week leading up to launch was not a 40-hour week.
No, right.
I don't know how many hours it was. It was a long week, but it was a lot of fun.
So the second phase of the design, and do you already identify all the members and the plans to build the car?
Yeah. Right now we're working with myself, Michael, Tim Shaw, and that's the main team at the moment. All of us working over at the engine lab. So working on getting that wrapped up. The goal is by the end of this semester.
Any other questions?
I got a question.
Yeah.
So what did you learn about the product development process?
That's a great question. I think some of the things I learned most about was communication and the importance of it throughout an entire project. Communication from the people at the top who have the ideas with the people doing the hands-on work, and also communicating and finding out who on your team has hands-on or past industry experience, manufacturing things, building things, communicating with those people and finding them and bringing them to the design people and getting them to talk to make a manufacturable design. I think that was the biggest thing I learned, and second to that was really the crucialness of planning ahead, looking at not just the explicit requirements, but any problems that might come up that the product is going to have to face, and trying to head those off before you get to them instead of after they become a problem later on.
So you said before one game that the spark plug failed or something.
Yes.
Right? So do you have to have somebody from your team there at every game to help troubleshoot that stuff, or?
There was, every game had at least one team member there. Most of them had two. And the primary reason was doing checks, and the secondary reason was the few people on the team, athletic department who were kind of unsure of it, wanted people there to push in the case that something went wrong. Thankfully, that never happened.
How did your coursework during your master's degree, what kind of role did it play here for you in this project, or through your learning experience in your master's degree at all?
I think during my first semester, I was in the internal combustion engines class, which also had a class project element to it. And it was a grad student class of, I think, 10 to 15 people. And that project really prepared me for this one, as it was kind of my first time as a leader in a class project, kind of having to communicate with people a lot. I like being in the details and in the weeds more, but that really gave me a chance to work on a top level manager view. And I think the majority of my classes, especially upper level graduate classes, have really forced upon me a lot of independent learning to go out and figure it out, outside the classroom, outside the lecture notes, and really go figure it out. And that's been a lot of what the project was, is here's a problem we have, and nobody's looked at this before, go figure something out.